Good evening, everyone. Good evening. Hope all is well. Hope everyone is doing all right. Still coming in. All right. So we're gonna get into chapter 7. Hopefully, you guys saw my email and saw what I asked about the definitions. Most of you sent it in, so I'm pretty sure most of you saw it. So don't forget when you get a chance, just like we did chapter 1 and chapter 2. 7.1 is our definitions. So I thought that was the easiest way to take care of that section. And then 7.2, I asked you to check out that lecture, and we'll piece together more of that with 7.3 and 7.4 today. But before we get started, anybody have any questions or concerns? Everybody good? Very straight.
At the end of class, do you mind going over a few of the problems from section 7.3 and 7.4 with me? It's just a few questions.
Of course I mind. I mean, what do you think I'm here for? Like, I mean, no.
Hello.
Yeah.
Hello.
Not here for that, but yeah, that's fine. That's fine.
Okay.
Uh-huh. Anybody else? I heard was that?
Hey, Professor, how you doing?
Hey, how's it going?
Man, everybody can laugh at me in the class, but man, I'm going strong headed to chapter 5 on that homework, man. Everybody come on. Let's applaud me, everybody.
I'll give it to you. I'll give it to you.
Thank you. Thank you, everybody.
You're almost there. You're in a good place now. You're good. You're in a good place. That's good to hear.
Man, I remember, I forgot who it was. And it was so funny because I forgot what her name was, but she was like weeks ago talking about the problem in chapter 4 that had like 26 steps or something. So I came across that problem, and you know me, I tried to write the answers down real quick while you were going over it with her. And I got to that same problem in the chapter review, and it's a whole totally different set of numbers. I was like, this is no help.
But you made it through it, though. You made it through it.
I'm still working on it. I've been plugging away at it, man.
I'm glad you didn't got to this point, because I know it's a little concerning at times, right?
Oh my gosh, more than concerned. I was like, man, I was like, Thomas the Train, like, I think I can.
All right, where did my pen go? All right, here we go. All right, guys, so let's go ahead and get in here. 7.3, central limit theorem for sample proportions.
So we starting off the rip 7.3?
Yeah.
Just like that?
I mean, I don't know what else to do. I asked you guys.
The video was 7.2.
I said hi.
Okay.
Oh.
Let me flip a couple of pages.
I haven't even seen that side of the book, Miss Lady. So go ahead, flip them pages. Let me know what it looks like.
So the central limit theorem. I could have wrote that a little better. I know y'all can get me. Central limit theorem. CLT for short. It tells us that if some basic conditions are met, then the sampling distribution of the sample proportion is close to the normal distribution. And so the reason why that's important is because, the normal distribution is our bell-shaped curve. That means symmetric about the mean, and that means we also can use our z-scores. So that's why that's important to us, being able to use our z-scores. Can I push down this?
How about those Red Sox?
Boo.
Come on now, cut it out.
Don't go there. Astros all the way.
Oh, you one of those cheaters.
Girl, bye.
No, I have a personal thing in the Astros. First, I lived in Texas, and my son is one of the personal top chefs for the Houston Astros. So.
Oh, okay.
Yeah.
Okay. There's some biases there.
So now he didn't provide the trash cans, did he?
Nah.
Yeah, bang on these, right? Oh man. So those conditions, the first one is that it's random and independent. So the samples that are collected are at random and are independent of each other. So that's the first condition. Just of course we scrolling up slowly, making sure everybody have a chance to copy. All right, can I scroll up on the black? All right, so large sample is the next one. So you want your sample to be large enough to have at least 10 successes and 10 failures. And of course, we're gonna go through what these mean when we put some numbers on it. And then we need a big population. And I'll scroll up on that in a second. All right, so that third condition, want a big enough populations so that it's if a sample size is collected without replacement, then the population is at least 10 times bigger than the sample size. All right, scrolling up. All right, CLT tells us that if our conditions are met, then the sample distribution of P hat, don't forget that P with that part of a triangle up there is called P hat, is approximately this notation right here, P, comma, square root of P times 1 minus P over N. Now I'm going to scroll down a little bit, give more reference to what that means.
That's P over 1, right?
All right, let me make sure I got what you're saying. Talking about right here? Let's see.
Yeah.
Right here? Okay. That should actually be P times 1 minus P. Like that's like parentheses. 1
Okay,
minus P.
gotcha.
And then
Gotcha.
it's all over N. Mhm.
Gotcha.
Can I scroll up on the purple?
One question right here at the end of the blue, where it says sample, is it distributing or
Distribution. Distribution.
P is, what is this abbreviation for the APP?
Approximately. It don't look
Okay.
like approximately to you? Like, no, it's
All right, thank you.
not a problem. I was trying to save on space. I think when I magnified it before, I think I had it more so like this, something like that. That's why I stopped right there. But since I got it this small, Oh, somebody coming in. All right, so from out of 7.2, we saw that this square root of p times 1 minus p over n is also standard error called SE. And don't forget this notation. We talked about it before when we first started talking about normal distribution, that when you have n, capital N, parentheses, and then a number, comma, the second number, that means that the first number is your mean, second number is your standard deviation. So they're saying that these conditions are met, then let's scroll up. That P is your mean, and then SE is your standard deviation. That can go. Yep. So I will shoot that to you. I'll try to make the video tonight. Yep. And boo Celtics.
Whatever.
Yep, not a problem at all. Not a problem. So before you go, Miss Moran, I just thought I would go ahead and show you this.
That's why I said go so. Babe, you gotta see this jacket he's putting up. Cause he got this Lakers. It's a nice jacket. Forgive me. It's a nice jacket. Right. Go Celtics. Thank you.
Oh, well, you know what? I didn't show you the championship ring that I earned last year.
Oh, the champ.
I got it. If this, if I won't, I know everybody's in class, so I'm not gonna take up the time. I would go
I
to my
apologize,
drawer.
class.
I would go to my drawer and pull out my championship ring for 2020. I mean,
Next time you're gonna have to pull that out. You're
right.
gonna have to pull that out. Good night.
All right, have a good one. All right, don't know how far we are. So if I scroll up too far, let me know. So, and then in the red, it says, if you don't know the value of P, then you can substitute the value of P hat to calculate the estimated standard error. We'll see the process. We'll see the process once we put some numbers on it. All right, scrolling up. All right, so this next example, let's return to pet world. That's referencing the last section. So we have a population of 1,000 people, and the proportion of cat people is 25%. We'll take a random sample of 100 people. So cat people are people who love cats. So that's the definition of cat people in this example. And like I said, that was established back in the last section when we first started talking about pet world. Are you done with the red? All right. All right, so what is the approximate probability that the proportion in our sample will be bigger than 29%? All right. So first, we're going to begin by checking the conditions for the central limit. All right, COT. So the first one is, is our sample random and independent? So remember, it says random right here, and independent means, the probability of choosing one has anything to do with the other or anything like that. So they're not connected. It's just you randomly choosing people, and they randomly chose 100 people in Pet World. So it fits the first condition. All right, the way we would test if we have at least 10 successes and at least 10 failures, that's our second condition. So we know that success, in other words, getting a cat person, we have a 25% chance of getting a cat person. So you take that 0.25 and multiply it times your sample. And so that'll give us 25. So of course that's greater than 10. Then if you don't get a cat person, then that's the other percentage of somebody else, whether it's dog person, lizard person, I don't know. They just talking about cat people, but that would be the other percentage. In other words, that 0.25 minus 1, that will represent your 75%. So 25% are cat people. That means 75% are other people. And that would be considered a failure because we're talking about cat people. And so that's how we'll multiply that times 100, and that'll be 75. So remember, for your second condition, you have to have the probability of at least getting 10 successes and 10 failures. All right. And then for that third condition, you need your population to be at least 10 times the sample. And so if you multiply 10 times 100, it is 1,000. So that's exactly 10 times the sample. So that checks off as well. So all three of our conditions check off. And that means we can use normal distribution as our model. Any questions or problems with what we've done up to this point? Right, holding on to the black. So always, when it comes to your notation, capital N is your population size. Lowercase n is always your sample size. All right, so next move is that we will calculate the standard error. So our population proportion is that 0.25. That's what it gave us. So it's 0.25 times 1 minus 0.25 all over 100. Take the square root of that. And of course, if you have a calculator, you can pretty much throw it in the calculator right there. I just went through some of the steps, that's all, to get us here to 0.0433. Always make sure if MATLAB asks you for the standard error, that you adhere to however many decimal places that they want at that time in that problem. So watch that. All right, so now we can calculate our z-score. Now let's go back to the problem. The problem, or the percentage in question, says bigger than 29%. So this 29% is going to be our p hat. So we find our z-score by doing p hat minus p over the SE, the standard error. So it's 0.29 minus 0.25 over that 0.0433. That gives us 0.92. Any problems, any problems? So, don't forget z-scores always round to 2 decimal places. Once you have that, you go to your chart and we will get the chart value of 0.8212. At this point, I believe that you all are pros at going to the z-score chart. But remember, you will look for 0.9 on that column and then the 0.02 on the top row, and where they meet at is where you'll get this value. All right, anybody holding on to the red? No. All right, so going back to our z-score happenings, or whatever you want to call it. I remember when we were doing with z-scores, keywords would dictate whether we use the chart value or subtract the chart value from 1. And we're bigger than, greater than, or to the right of means we need to subtract our chart value from 1. And so that's what we did right here in the purple. If it said less than, we would have just used the chart value. And then just make sure you pay attention to what my math lab wants from you. Could want it in decimal, could ask for the answer in percentage, or they could even say about 18%, So all 3 of those answers are legit answers. So just make sure you pay attention to how my math lab wants you to input that answer, And so if they put it in sentence form and they say about 18%, blah, 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 then that's where they got that answer from. They just rounded the 17.8 up. So. All right, questions on that before we hold on to the next one? All right, everybody good with that before we go to the next one? We're still on the purple. All right. So Samuel Morse, inventor of the Morse code, claimed that the letter used most frequently in the English language was E, and that the proportion of E's was 0.12. We took a random sample with replacement from a modern, I forgot to put A right there, so that's why I wrote that like that. From a modern day book, our sample consisted of 876 letters, and we found 118 E's. So P hat is 0.1347. And so that 0.1347, you see I wrote it in red right here, came from the 118 over the 867. So these two numbers right here. So out of that 867, 118 of them were E's. All right, so I'll give you a chance to write that down before we move forward. All right, scrolling up. If I go up too high, let me know. Find the probability that if we were to take another random sample of 876 letters, the sample would be greater than or equal to 0.1347. So every math lab problem is probably not going to make you check the conditions, but of course, I want to make sure you guys know how to, just in case they do ask for you to check the conditions. Remember those three that we need to make work or make happen, or see if they happen. Random sample, that's the first one, and they always tell us or infer, that we do have a random sample that's independent. Then 10 successes, 10 failures. So once again, you take your sample size, in this case is 876, multiply it times the population proportion, which is 0.12, and we get 105.12. And then the next one, take that 1 minus p, which is 0.12, 1 minus 0.12, which is 0.88, multiply that times that 876. That's 770.88. So once again, that's greater than 10. So that checks off on both. Need both of them to be greater than 10. And then for the population to be 10 times the sample size. So, 10 times 876 is 8,760. And, the book is going to contain far more letters than that. Even if you don't know all of them, the book should contain way more than that. So that should check off. All right, any questions on the conditions? All right, pretty good. So calculate the standard error. That's square root of p times 1 minus p over n. So our population proportion in this case was at 12%, which is 0.12. So 0.12 times 1 minus 0.12 over 876. You take the square root of that, will give us that 0.010979. Any problems, any problems? After you have your standard error, go ahead and calculate your z-score just like before. P hat minus P over SE. So 0.1347 minus 0.12 divided by 0.010979. And that should give you 1.34. All right, scroll up, everybody good? Once again, hit that chart, there's the score chart, 1.34 will give us 0.9099. And remember, the value that you pull from the chart will always be less than. That will always be less than. Let's go back up to the problem. Yep, we want it greater than. So we'll do 1 minus that 0.9099. All right, so that's the answer. Any questions? Any questions?
Just a lot to intake.
I can imagine. I can imagine. That's why I'm not giving you a test today, right? You know. I think that's That's it for 7-3.
Thank you.
Yeah, no problem. Anytime.
Wait, when are we doing an in-class test?
Oh man, when you want one?
I don't. Please don't. They just gave me a new position at work and I don't know how to handle it yet.
Oh man, well, congrats.
Congratulations.
Yeah.
No, it was more like I was voluntold to do scheduling. I don't want to do it.
Oh, one of those. They asked you, but really you didn't have a choice. I'm sorry.
Yeah, and everyone wants to schedule their shifts at 11:40 at night, and I get 30 notifications on my phone.
I'm sorry. I wish I could help by not giving you any math tonight.
That's fine. I feel bad because I'm a little behind in this
Mhm.
class, but I'm catching up slowly. So
Okay. Well, I'll try not to hurt y'all too bad because I do have a plan to try to help us massage not doing but so much at one time. But I'll tell you those plans later. You know, we can go ahead and do because do 7-4 today.
Please
And,
don't stress us out. Please don't stress us out Thanksgiving
No.
week.
It's gonna be easy. You know what I'm saying? Just okay. Basically, okay. You sound like you're nervous. All right. So what I'm gonna do is somebody gave me an idea. One of your classmates. I won't tell you who it was because then y'all might not like it if y'all don't like the idea. So I'm not even gonna tell you who it was. But I thought it was a good idea because a lot of times we do have this time. We finish early, and we already got sent to the principal's office before about finishing a little early, right? So what I can do is I can send you guys like maybe a 10-minute video. That would be like our justification, like, hey, we looked at a video and it has something to do with math and has something to do with health or different applications. And all you have to do is just write down 5 things that you saw in the video, and that'll be your assignment. And that'll be like an easy grade. And it still be like anybody asks, I'm like, yeah, man, I sent them a video, you know what I'm saying? Something like that. And that way we can massage this thing a little bit. And
Thank you, whoever promoted that idea.
yeah, thank you.
That sounds good.
That's cool. That's cool. Okay.
Yes.
Cool.
I have a question too, actually. It's about the definitions. You
Mhm.
told us to send them into you as soon as possible.
Mhm.
When's the cutoff for that? Because I have them done, I just have to find the spiral and where it went with the definitions in it.
Just send them to me. You'll be all right. It's all good.
All right, good.
Mhm. All right. Can we scroll up on this one? 7.4 is all we'll do today because 7.4 is the end of chapter 7. And I think there's a lot of steps in this stuff and a lot of content in it. So I don't feel bad for I don't feel like anybody can tell on me on this case, this front. I'm telling you, it's gonna always be in the back of my mind, y'all, until the end of the semester.
It became a lot of steps in 6.1.
In 6.1?
Yes.
Well, according to whoever told on me, I'm not doing enough. So, I'm just, I don't know. Yeah, but let's look at 7.4 and we'll knock out 7.4.
I don't
And,
think that was our class.
It might not have been. I just don't, and that's the problem. Y'all know that I'm all self-conscious now because I don't know who did it. You know what I'm saying? I just, I had a ninja to, fire a ninja star at me, and then I don't know. I'm like, where did he go? You know what I mean? So it's all good though. I'll make it. I'll make it. So
I can say though that I have hands down recommended you to other people because I have a friend that's taking a different statistics class, and I told her how you're running things, and she's like, please, can I switch, please?
Oh, well, I'm glad that'll help me keep a job, I appreciate it. I most definitely appreciate it. And then say again.
Sorry, I was just gonna say the way this class is structured, honestly, it's probably one of my favorite classes because I can literally, if I am behind on others, I can do those and then come back to this and stuff like that.
Okay, cool. I appreciate it because when I hear stuff
I
like that,
agree.
yeah,
I agree 100%.
I appreciate it.
Yeah,
'cause,
chemistry's kicking my ass.
really. Oh,
Yeah, because
man.
everybody wants a lockdown browser on this.
Mhm.
They make it so.
Right.
Oh, my
Yes.
science class is making me do a discussion, and I got 5 points knocked off for an intro to myself because there was one spelling error.
Oh, wow.
She's
wow.
not nice.
Your teacher. Who's your teacher?
Morales.
Oh no, she capping. I took what is it? What's her name? Miss Van Dyke. I think that's her name. That was my science teacher.
Is she good? Is she nice? Because I may have to take chemistry
Yeah, she's really nice. You gotta kind of really listen, because she's got a very strong accent. So you really gotta listen sometimes to what she's saying. Cause she'll be like I remember I was sitting there and she was talking, she's like, do you have questions? And I said, do I got what? And she said question. I was like, oh, you're saying question. And I felt really bad because her accent was so strong. I didn't know what she was saying.
Yeah, no, this chemistry, it's chemistry. She wants a discussion. She wants a test, a sample test, and then an exam all in 1 week. And then
You have
to
for
go
chemistry.
Yeah, that's Morales.
Oh,
And that's online. And it's not even like we don't have a set time to meet or anything like that. It's all what's the word I'm looking for?
Asynchronous.
Like this one.
You're at your own pace.
Yeah, asynchronous.
Asynchronous. And
Mhm.
here's the thing, no, it's not at your own pace because I have to have everything done by either Wednesday or Thursday, and
Mhm.
that is it. Yeah.
mm.
Yeah, and then you have to do the labs on top of that, and she's got tests and exams and discussions all about that too.
Yeah.
For 4 credits. That is it. It's 4 credits, and she wants all
I
of
know,
that.
right? Like how
Wow.
much you got to do for 4 credits or any other, man. It is a lot of work. I'm not gonna lie to you on that one.
Yeah.
I took 13 credits over the summer, and people thought I was crazy then. This is harder with her than my 13 credits in the summer.
Wow. Wow.
I'm
Well-
dying with what I got 12 right now, and I feel like I'm getting ready to fall out.
Wow. Well, sorry. I don't.
No, you're fine. Your class is great. I appreciate it. I really do. Like this
Don't
is
take it
the
offensively,
easy-
but
the
this
easy
is the
grade.
easy class for me, and I'm loving it.
Oh, no. I don't. I mean, part of my rationale, just so you can see where I'm thinking, part of my rationale is that I know there are enough instructors out there that are like that I try to pull back, you don't have to get it here. I know you're gonna get it somewhere else. You know what I mean? So, I try not to be that person because I know there are a lot of different personalities out here, and some people feel like you need that strict, hard situation. So I mean, it is what it is. I just try not to be that, even though we do have content that we have to cover, assignments have to
Right.
be turned in and everything. I can't compromise on the fact that we have to do stuff, but at least I can compromise on the fact that how we do it. You know what I mean? How it's presented and the leniency and everything like that. So yeah. So
It's
like
much
I said,
appreciated.
well, I
Yes.
appreciate that. Like I said, knowing that it is, appreciated, and that lets me know, okay, I can keep doing this the way I'm doing it because it helps out, So yeah, that's good to hear. Not the fact that y'all struggling on the other end, but the fact that this is all right. So yeah. All right. So 7.4, estimating the population proportion with confidence intervals. I think at this point, you guys have already copied down the title. So confident intervals are often reported as the estimate plus or minus some amount. And so we'll talk about how we're going to determine that some amount. So just an example here, 53% plus or minus 2.7%, or symbolically, would actually be a plus, and a minus, just like that. So. All right, the sum amount in this case, the 2.7%, is called the margin of error. Oh. All right, let me know if I go up too far. So the margin of error tells us how far from the population the value our estimate can be. Our confidence interval provides two pieces of information.
Can you scroll back up, please? Well, yeah.
That's good enough?
Right
Or
there. Thank you. Uh-huh.
no problem. All right, let's scroll up, scroll up. Excuse me. So a confidence interval provides two pieces of information. First is a range of plausible values for the population parameter. So you do the plus and minus. So you see how if you were to add 2.7 to the 53% and then subtract 2.7 from the 53%, gives you those two values there. So it gives you that range. And then a confidence level, which is our level of confidence in this interval. Well, of course, just like before, hopefully it'll make more sense when we put numbers on it. All right, scroll up. Also, the confidence level measures the capture rate for our method of finding confidence intervals. All right, holding on to 2. All right, so selecting the margin of error is similar to the empirical rule. P hat plus or minus 1 standard error. Just like and that's 68% confidence interval. So just like with empirical rule, 68% of your data is within 1 standard deviation of your mean. So this flows the same way, 95% confidence interval. You do plus or minus P hat, plus or minus P to the P hat, 2 standard errors, and then P hat plus or minus 3 standard errors, give you that 99.7 confidence interval. So the same percentages from the empirical rule, going out 1, 2, and 3 standard deviations. All right. So the confidence level here, 99%, 95%, 90%, 80%. Let me see. I think it's on the head. So the margin of error that we're going to use, 2.58 standard errors, 1.96, which is about 2. For the next one, 1.645, and then 1.28. And these are going to be our Z asterisks, or Z asterisk or Z star, but that's what these represent for us. And you'll see that in the formula in a second. All right. And so Ray asked, I guess we could have scrolled up a little bit for the red statement, but those are commonly used confidence intervals. And you see in the problem, they'll give us one of those, and then that will tell us to use one of these to calculate the confidence interval. All right, scrolling up. All right, so finding the confidence interval. So the formula right there is P hat plus or minus M, and M is going to be that Z asterisk times your standard error estimate. And notice we'll calculate that with this. Very similar to what we did in the last section, P hat times 1 minus P hat over N. And take the square root of that result. And that M is called the margin of error.
Can you just scroll up just a little bit real quick? I just
Sure.
need the purple you had on the side.
Hmm.
The arrows, okay. And that's the Z-score, is that what that's for?
No, it's Z asterisk. And so that's what we're going to use right here. We'll
Okay.
go down a little further. Mhm.
Okay, you can go down. Thank you.
Mhm. Of course, let me know if I scroll up too far. All right, can I scroll up? All right, ready to go to the problem. So next example, recall that Morse believed the proportion of E's in the English language was 0.12 and that our sample showed 118 E's out of 876 randomly chosen letters from a modern day book. Am I done with these statements up here? So tell us to find a 95% confidence interval for the proportion of ease in the book. And then is the proportion of ease in the book consistent with Morse's point 12? All right, can I scroll up? All right, so we're looking for that confidence interval. So we are going to find the estimated standard error because we don't have a population. Let me see, we do have that. Okay, so we'll find our estimated standard error first. Remember that was part of our confidence interval calculation. We go back. So we needed this piece right here. And so we would do that, p hat times 1 minus p hat over n, take the square root of that. Remember, we found p hat to be that 0.1347. Remember, p hat is taking your sample and then whatever characteristic you're dealing with and put that over there. So it was 118 E's over 876. So that's how we got p hat. So just remind you how we got p hat. All right, so doing your calculation will give you 0.0115349 once again. When you're doing your calculation, don't matter how many decimal places you go out, because the further you go out, the more accurate you be. But if they just want an answer, like if they just ask you what's your estimated standard error, then you make sure you hold true to however many decimal places they want. So if all they want is 4 at the answer, then just put in 4. But when you're doing your calculation, you might want to go out, 5 or 6, because the more decimal values you go out when you're doing your calculation, the more accurate your answer will be. So then we're going to find the margin of error. So it's that z asterisk times your standard error estimate, your estimate standard error. So we just calculated that piece, but the z asterisk come from the chart. So if you go back and look at the chart, we had a 95% confidence interval that we wanted to create. So we would go to the chart and use that 1.96. That's what corresponds to that. So put a video. So there you go right there, 95%, 1.96. That's why we have 1.96 there. So you just multiply that times your standard error estimated standard error. And that gives us this value right here, 0.022608. Everybody still holding on to the green? And then we can find the upper end of our interval and the lower end. Doing p hat plus or minus that margin of error that we just calculated at 0.022608. And once again, how far you go out in your decimal, Math Lab will let you know. All right, everybody good before I scroll up? Make sure we're all right. Everybody okay with how we got those numbers? All right, so the conclusion, and I'll just put it all in words. Of course, let me know if I scroll up too far. You know, the way my math lab work is they'll have a written sentence that you would click, yes or no to or whatever, or pick the right one. But if we were to put all of it together, we are 95% confident that the proportion of ease in the modern book is between 0.112 and 0.157. And this interval captures the 0.12. So this shows that it is plausible that the population proportion of ease in the book is 0.12 as more suggested. Because remember, they was asking, was it plausible that 0.12 was correct? And so since 0.12 is in between, our confidence interval that we've established, then it is possible that he was correct. So now if he had suggested 0.27, of course, 0.27 is greater than that 0.157, then we would come to the conclusion that he probably wasn't correct, or he may not have been correct with his statement, or if it was less than the 0.112. Any questions? All right. Oh, that's all we had? Okay. So this section only focuses on that process. Okay. Questions on anything before we go anywhere else? Make sure we're good. All right. So is everybody done writing before I go to another page? Are we good?
Hold on, I'm right at the end.
Oh yeah, take your time. Take your time. All right. So that is pretty much it for chapter 7. It's pretty much holding true to the process that's given it and the steps. So I know one of your classmates had questions on something out of 7.3 and 7.4. So I'm going to address those questions. If you don't want to sit back for her questions and you don't have any questions and you're good to go, I'm not going to hold you, hostage. I will, get my stuff, and just look out for an email from me on the other thing I was talking about, the videos where, like I said, it should be some easy points for everybody and just easy assignments. Like I said, just to, buffer, not staying in class all the way till 12 o'clock, like we're supposed to be, right? And then, and we'll go from there. So, like I said, just look out for an email from me, and we'll be talking about that type of stuff as we move forward. So, any questions, concerns, or comments before I release? Everybody good? Everybody straight?
So what were you saying about the tests when those are going to be released? Is that what you were talking about, the videos?
No, video is just gonna be just like a video that I was sending, like maybe a 10, at the most 15, something like that, some few minute video where you would take a look at it, write down between 5 and 10 things. And I'm still, formulating exactly what I want to do with it, but you'll write down what you see in the video, write down some facts you found in the video and then shoot that to me, and that'll be an assignment grade. And it'll just be another way to, earn some easy points. As far as tests are concerned, all of your tests are open except for what we haven't covered yet. So you should see, at least I thought chapter 5 and 6 test is up.
Yes, it is.
It is available. Okay. So you wouldn't see chapter 7, chapter 8 yet because we haven't covered chapter 8. And then so I'm probably going to make that available once we get close to closing out chapter 8. The only test that's going to be proctored for us is going to be our final exam, because I have to do that. Can't really compromise that. And we'll talk more about that when we get closer to closing out the class.
Okay. Well, so for the tests, it's under in the Pearson site, right? It's supposed to be under assignments, because I only see the homework assignments when I click on the assignments tab. I don't see, I see test 1, which is chapters 1 and 2, which I took, but and then I see the chapter 3 and 4 test review, and then chapter 5 and 6 test review, but I don't see anything where it says test.
All right, not a problem. Let's make sure everybody's good. Make sure everything's showing up where it's supposed to be before you guys roll out of here.
Because I've done pretty much all the homework, and I was waiting for the test to be posted, but I didn't see anything. So
Yep. It's supposed to be, but if not, I can make it available now. I don't have a problem making sure, because sometimes I forget. Like somebody emailed me about a test review that wasn't posted, or it wasn't showing up correctly, so I had to go in and make an adjustment. So, well, let's do this. Let's go back to the main menu and assignments. So test 1, test 2. So you should be able to see everything up to test 3. Now, what may be the case is that it may be on just homework. I don't know if you ever hit that tab or try hitting that tab, or you can change to just test and just see your test.
So I'm on the assignments tab. Where, what other tab am I supposed to be?
Well, if it says all assignments, you should see it. So when you scroll down, you should see a green diamond. That'll be that test, and then that's test 2, and then test 3. So now, if you still don't see it, try clicking this and hitting quiz test. Let's see. You know what? Let me see. This Miss who's asking this question? Is that Miss Merkel?
Yes.
You know what? Let me do something. I think it's because you're in the old shell and you never switched over.
Oh, I see. Okay, so if I go to the top.
Yeah, let me see. Great book. Nope, wrong one. I know somebody was in the old shell and never switched over. And I said, well, you've been in there this long, it'll be all right. Let's see. Okay, we're great book. Okay, there we go.
Are we doing the quizzes or just the tests?
Oh, no, wrong one. It should just be tests. It should be homework and tests.
Okay, because I did go to the top, and I just when I click all assignments, it doesn't show me the tests.
Yeah. And I think that's why. I'm sorry. Go ahead.
Sorry, but when I hit quizzes and tests, then it shows me all the tests, but it also shows me quizzes. So we just have to do the tests.
Well, that's because you're in the old shell. Yeah, you're the only one in there.
Really?
I think I saw when I went to go check attendance, because I have to do a report of people that's attending. I saw that you were in there, and I didn't tell you because you were in there. So I was just like, it's all good. And so I just,
oh my God, how do I get out of that?
It's not that big a deal. It's just that I need to go. If I were doing final grades, I would not see your name under the new shell, and then I'll just go to the old shell. I just need to open up the test for you. That's all. Yeah. So unless it's not that big a deal. It's just something extra that I have to do, and I just have to remember to open up the stuff for you.
Okay. Well, if I see a 0, don't worry. I won't let you forget.
Yep. So it should be open for you now.
Awesome. Thank you so much. And
Not a
so
problem.
just the test and not the quizzes, correct?
Right. So you shouldn't see anything but tests. Let's go to announcements. Not announcements, assignments. And so when you do, even when you see, all you should see are these 3.
Nice. All right. So test 2 and test 3. So there's only 1, 2, and 3, right?
Mm-hmm.
Okay. Perfect. Thank you so much. Yeah, I see
All
it
right.
now. Thank you.
Not a problem. All right. Let's see. So.
All right. So, Mr. Tucker,
Mhm.
I wrote the questions right there in the chat. For 7.3, can you help me with 1, 2, 3, and 4? And 7.4, 1, 2, and 3?
So you just want me to do all your homework? That's.
No, I just need help. Because I really tried. Like, I really tried to do it.
All right. So it says here, find 20% ranges.
I can't see.
You say you can't see? Somebody said you can't see?
Yeah, because I need help with those too.
All right. So you can't see.
My screen just shrunk all of a sudden.
Oh, okay. That's not on me. That's on you saying that. Okay. All right.
I'm gonna log out and log back in.
All right, cool. So it says according to candy company packages, we have 20%. All right, let's do this. Do that. All right, so certain candy contain 20% orange candies. All right, find the approximate probability of random sample of 100 candies. And can contain 25% or more orange candies. All right, let's see if there's anything else that I need. All right, so we need to calculate our standard error first. P times 1 minus P over N, take the square root of that. All right, so it should be 0.20. 1 minus 0.20 all over 100. All right. So that should be 0.04. All right, so this is always the first move to make, find your standard error. And then we're going to convert it to a z-score. P hat minus P over your standard error. And make sure they didn't want anything else. Yep, that should be good. All right, so P hat was 0.20. I mean 0.25. 0.20, all of 0.04. For those who are watching, y'all all right? Make sure if you have any questions on what I'm doing, don't let me just blow past anything. So we get our Z-score of
I'm
1
just
point.
trying to understand the steps.
So we okay with what I've done though?
Mm-hmm.
Okay.
Where did you get that bottom number from, the 0.04?
Right here.
Oh, okay.
Yeah, this
So that's the
process. Right.
second, okay.
Mhm.
Okay, so my problem's a little different than yours, but I'm trying to follow along with you. So in my problem, I put 0.19 minus 0.16 divided by 0.018. When I did that, I got a negative number.
Oh, it's fine.
Oh, okay.
Yeah, Z-scores can be negative.
Okay.
So just making sure we're matching up. Let me go back to, hold on. So just making sure you matched up everything, you know, accordingly. This was our P, this 20% right here. N is 100, and then this was P hat. So, you know, according to whatever numbers you have. Excuse me, I'm sorry. All right, so then we go to the Z-score chart. 1.2. Where's the thing at? Okay. 1.25, we got 1.2. All right, so that's what I'm getting from the chart.
Do you mind sharing your chart? I'm trying to find the negative 8.70 that I got for my question.
All right, so make sure you go to the negative side because there's a positive side, but then there's also a negative side. So you say you got negative what?
8.70.
Negative 8.70? Or did you say negative 0.8?
Yeah, that's what I rounded to.
So,
No, it was negative 8.70.
Oh, no, we did something wrong there. It can't be that high because negative 3.4 is high as they go. So let's see what numbers you have here. Give me your numbers like this to get your Z-score. What did you have?
Okay. Oh, the one's right there. I put 0.19 minus 0.16 divided by 0.018.
0.018. It might be with this, with your SE.
Okay. So that part I put 0.16, and then in parentheses I got 1 minus 0.16 divided by 400.
Hold on 1 second. So
Okay.
I was just checking this first, and I want to make sure I got 0.19 minus 0.16 divided by 0.018. I got 1.67 here.
I always get something different than I get.
Because subtract the top, you get 0.03. And then here you get 0.018, 1.67.
Okay.
And then 1.67, of course, is a valid Z-score.
Okay. Just as it say above, you just get the number on the chart, right?
Well, we'll get there. I just want to make sure we get the chart value.
Oh, okay.
Yeah, we'll get to the above part. But yeah. So are you getting 1.67 now? Or?
Check again. Yep, I got it this time.
Okay. All right. So since it says more than, let's subtract that from 1. And that's all that problem wanted.
Y'all doing something.
You just got clapped.
All right. So how we doing with that problem?
Yeah, I put it in here, but it ain't taking it to round to 3 decimals.
Mm-hmm.
So
Mm-hmm.
so it should be 0.1056. That's what we should put in there.
Yeah, because it want 3 decimals. Mm-hmm.
It still said it was wrong.
All right. So let's see what numbers you have. So for P, you have 19%. No, you have P hat is 19%, right?
I'm sorry. What did you say?
For your values. So you have P is your first value that you come across, if I'm not mistaken. Let me see.
Yeah, 16%.
That's 16.
Yeah.
And then you got that one is 19.
Yeah.
And what is your N?
400.
That's 400. Okay, so let's see. All right. How about let's see if that makes a difference. Hold on, let me ask you this. Did you put in 1.106?
Yeah.
That's my answer. You had to go to the chart for your value, which was 167. Remember, I was just following with that's my answer. So you would go to the chart for your Z-score was 1.67. So you would go to the chart for that.
Okay.
So you got 1.6 right here, 7 right here. So that's 0.9525.
Then I would subtract it from 1, right?
And you subtract that one from 1. Uh-huh.
Okay. 1, 0, 4, 7. I think I'm still having trouble trying to read the chart, the Z-score chart.
Mhm.
So I've been trying to work on that.
All right. So tell me what you got. What you say
Okay,
you're having
yeah, that
trouble.
was correct. Okay, so I'll go right here. This was 1 which one was it? 1.6. So then it goes into 7. 1.6 and come over here to the 7. 6, 7. Okay. Okay. All right. I think I see how we got that one.
Okay. Okay. So you okay with reading the chart? You
Yeah.
find your 1.6 over here, and then the 7, which is this value up here.
Okay.
So whatever comes in front of that, you have this last digit that's always going to be up here, and then everything
Okay.
in front of that will be on this column right here. And then where they meet at is the chart value that you put, you take from the chart.
Okay. Okay. So yeah, I understand that one a lot better than number 1.
All right. All right. Jury should have same racial distribution. 29% reason. Conditions. All right, so because sampling distribution for sample proportion is approximately normal, it is known the probability of falling within 2 standard deviation errors is 0.95. That comes from the empirical rule, 2 standard deviations or 2 standard errors is 0.95. 3 is 0.997. 1 standard deviation is 0.68. So, and that goes back to where it goes right here. So that's no calculation on that. Just remembering the empirical rule and standard errors going 1 out, 2 out, and 3 out. Especially therefore the probability of falling more than 2.
So in the problem, what number do I focus on to get that?
They said 2 standard errors.
Okay.
So that would be this right here. So if they said 1 standard error, then you would have chosen 68. If it said 3 standard errors, you would have chosen 99.7.
Okay.
Yeah. And then next one. And then the next one, therefore, the probability of falling more than 2 standard errors away is just that 0.95 minus 1. That gives you 0.05. It's just the rest of that.
Okay.
So you would just subtract that from 1 and got 0.05.
Okay.
All right, so this is when you have to go through those steps that I did today. So it says, according to the regional bar, approximately 64% of the people who take the bar exam practice law in the region pass the exam. Possibility at least 65% of part of the exam. So sample proportion is 65%. The population proportion is given right here, 64.
Okay, so mine's is 63. Okay.
And then check the assumptions. 10 times would be 4,000 if a simple random sample 400. So here's where you have to do these steps here. So you have to do these right here, where you do n times p, n times 1 minus p. So your n, so your n in this problem is 400. And then we just did p, which is 0.64. Let's see. And so it's just walking you through the steps that, like I said, that I introduced tonight.
Okay.
For the I'm still on the second part.
Mm-hmm.
You said plug into the equation, so we.
You would do n times p. So n is your sample size, which is 400 for me.
Times p.
And then p is 0.64.
Times 0.63. Okay.
Oh, okay.
Y'all can ask questions too, because I'm lost.
Wait, you the one who said you had questions.
Yeah, but they said she need help on the same one.
Don't be trying
I
to
do
put,
too.
don't be
I'm
trying to
still
peer
confused. My thing is, I can have trouble with the Z core, the Z scores.
Yeah, me too.
You gonna be a little more specific? You said you
Like
had trouble
sometimes
with
I
it?
come up with negative numbers, then it's like
Mm-hmm.
when I plug in my answers, it should have been the positive number.
Do you have an example of what you're talking about? Because
No.
I know it's okay for your Z-score to be negative because you got a negative side of your chart, but it just depends on what's going on. So you have an example of when that occurred?
I'm trying to find one of the problems. Hold on.
They're trying to peer pressure people into asking questions.
Yeah, because it's frustrating to me trying to get it.
I walk away.
And I really sat down and really tried to do this last night.
Did you look at the video?
Yeah, I did.
Oh, okay. Okay. I want to say you trying to do this thing cold turkey. We just talked about it tonight.
No, I looked at the videos you sent.
Oh, okay.
So how did you get the expected number of people that passed was 256?
You do N, which is your sample size, 400, times P, and that was 0.64. So that goes back to what we did here. And we have to test it, this and this. So you need those two numbers. Both of those numbers have to be greater than 10 in order for you to keep going. So we did whatever your sample size is. In this case, it was 876. And then whatever your percentage is, your population percentage is, and that for this one was 0.12. And we got this number. So in the problem that we're looking at, my percentage or my P is 0.64 and my sample size is 400.
Oh, okay. I hate it here.
Say what?
I hate it here.
So I got to find the standard error part, and then the other one for the p hat, wouldn't it be the number we just got, the zero, the number above it?
The point, yeah, the sample proportion. They say the sample proportion is minus 0.65. So whatever they say for yours, the sample proportion is.
Yeah, but it's two p's. So I would use the 0. The one ahead of it first, right?
Let me make sure. Yeah. So are you talking about right here? Or are you talking about right here? You talking about with the Z-score?
No, I'm talking about the last part there. Would I be using the number we just got for the first P?
So
yeah, I already did that.
You this one you find what you're talking about right here. So P hat, this right here, this first P is your sample proportion.
Okay.
And then P is the same P that you use here, which should be, for me, it's 0.64, which is what I got right here.
Yeah, mine is 0.63. And then over standard deviation, that would be the 0.24.
Hold on 1 second.
Girl, we need to try to get together sometime, do these problems.
I know. Jesus, I'm still confused.
It's like trying to learn it all at once here, just be too fast.
Yesterday, I just walked away. I was hollering. I was like, ooh.
Me too. And I really did try. I really did.
Okay, so yeah, you got that one. And then the more we get into this, the more the equations.
Right. Just like I just did what he told us to do for this last part, and it still didn't come up right.
Sorry. All right. So what's going on?
Because I did what you told us to do. I plugged in the numbers from up there. The one of the P's was 0.63, and then the second part you said use that. So that was also 0.63. So divided by the 0.024 I got for the standard error.
Oh, you said both of these were 0.63 for you?
Yeah.
No, they should be different. Okay, so P hat, the first number should be right here. Is for me, you see it's 0.65. What number do you have right there?
Oh, 0.64.
See?
Yeah. Let me try this one more time. And I don't have to, okay, never mind.
Oh, okay. So okay. Minus 0.64.
Now, Ms. Spencer, was I in the middle to answer your question, or you already answered your question?
You already answered mine. Okay. I'm still confused though.
Is there something I can do to help bring clarity, or?
I just gotta walk away for a minute because I've been working on this since yesterday.
Yeah, it's possible. Sometimes math is like that. You got to take, go ahead and walk away.
Okay, so I got that part. Did you get your part like that?
You talking to me? Or you talking to
no, I'm talking to her. I was wondering if she had got it because I finally got mine.
No, I think I gotta walk away from it
Okay.
because I know it's right there in front of me. I just gotta walk away.
The next part, they find the approximate probability at least 0.5 area of these normal curves.
So that's gonna be 0.42 for me. And find the probability is at least. So they're showing you when you say at least is here, and then you're talking about everything more than that. So once again, this is more than, so we need to go to the chart with this point more minus 0.42. So we need to go to.
Oh, okay. Yeah, mine's 0.42 too.
Oh, okay, so we need to go to the chart for 0.42 and see what z-score we get from, see what chart value we get from it. So you look for 0.4 on the column and then 2 up top. More steps on this thing.
7.
Let's see how much more. Hey, messed up. Anyway, I'll just figure it out. Probability represented by the area to the right of.
I got you something.
Oh, she said she's so cute.
Mm-hmm. Let me see which one of these I get wrong. Oh, this. Oh, I put a 0.65. Hold on. Probably represented by the area to the right of. She all right.
Don't do her like that. I have 3 granddaughters.
Oh, okay. Just seeing about these. All right. So have you got your probability right here yet? You got the 0.337?
I'm just watching at this point. My brain fried.
So notice what they're asking for here. Probably represented to the area to the right of 0.42. You're talking about the z-score.
Okay.
Because the question asked at least. They got that from the question, which translates to a z-score of 0.42.
Mm-hmm.
And that means it's going to be 4.42 or greater. That's what at least means, 0.42 or greater.
Okay.
And then the probability is this right here, converted to a decimal, and they said round to the nearest whole number.
Okay.
I just converted it from a decimal to a percentage. So that's how I got it, 34%. We decimal 2 places to the right.
Okay. The chapter starts for 5 and 6. It's not this stuff. It's not anything related to. Oh, okay. I mean, I was feeling good up into this chapter.
Well, gotta give yourself a chance to digest it.
Yeah.
Like Miss Penson said, sometimes you do have to walk away, give yourself a chance, and then come back to it.
Yeah, and the reviews help too. I like doing the review.
I love doing the reviews.
Yeah, but it's like 50 questions for 25 questions on the test.
Except for that review for chapter 3 and 4. Oh, you killed us with that.
I think I was supposed to change that and I forgot to go back and change it. So my fault. Yep, I need to go back and revise that. I mean, I guess it won't help y'all, but help the next class, right? All right, what else we got?
Then the next question, I had got part A and B. I just got stuck on C.
Find the approximate probability a person who's guessing will pass the test. All right, let's see if what they ask you. True, false, 2 answer questions. 55, what's the probability a person will guess correctly, true or false? Yeah, 50%. Okay, I'm with you. What's the probability? Incorrectly, one question. Yeah, got that. So find the approximate probability that a person who is guessing will pass the test.
Oh, this is plugging in the numbers, all right? Okay.
All right, so that all they want from us? Okay, so he just wants to do the same thing. I didn't think it was gonna be that easy. All right.
It wasn't 0.5.
Oh, it was 0.5 as a decimal?
Yeah.
All right, I was about to put in some work. I was about to say, okay, what we doing?
Right.
Yeah, you're right. It says decimal. Okay, probably the person will guess incorrectly one question, right? So that should be 0.5 as well. It's true or false. If anybody's watching, you know, you have a question on what I'm doing, feel free to ask. But I know she said she already had those, so find an approximate. Okay, so this is where doing what we did last problem comes into play, where we have to do your SC, standard error. Our P is 57 and N is 110. Well, for me anyway.
It's 62, so 0.62, and then parentheses. Ooh, the 0.62. 1 minus 0.62, right?
Mm-hmm.
Divided by the number, which is 140 for me.
$57, 110.
Okay, so I got I got 0.0410.
All right, so I got that. And then we need, see, I need my P hat.
Would that be 0.60? I mean, that would be in the problem, right?
You know what? I should not have did that. That a passing grade is 0.57. I think that 0.57 was P hat. Oh no. And 0.5 was P. That is what I should have did there. Yeah, that's what I should have did. So in actuality, should have did 0.5 right here.
Okay.
And so point is going to be 0.57
0.5
times 0.5 over this new SC. 0.5 minus 0.5 divided by 0.5 times 0.5 divided by 110. Close. For the Z-score, that's 147. $92.92.
So I got nothing nowhere near what you got. So I probably got the 0.62. I mean, got 62%. So when I got to my Z-score, I got 0.62 minus 0.5. And then for the number above it, I got the 0.423.
All right, so hold on. So your SE, did you do 0.5 times 0.5 over, what was your?
I think I see what I did.
Okay.
You know, I'm always missing a number. 0.62 minus 0.5. All right, so I got 2.84. Can I see your Z-score chart so I can look for the 2.84?
Did you do it? No, I didn't.
I know on the side I go to 2.8. Okay, I was about to do it. And then I go over here to 4. 3, 4, so that's 0.9. Oh, 0.997. 0.9977. And then I'm going to minus that by 1.
Because we want to know who passed it. So in other words, get greater than the value that we're looking at. So.
All right, I think I'm catching it. I guess not, because it gave me this crazy number, like 2.3 E minus 0.3.
Hold on, you did. You had, what was your, excuse me, what was the chart value you got?
2.84.
No, I'm saying like from the chart that we just got.
Oh, 0.9977.
9977. And then subtracting that from 1. That gives you 0.0.
Let me see what you
From the 0.0023.
9977. Yeah, it gave me like this weird thing, 2.3 E minus 0.3.
Oh, that's because your calculator put it in scientific notation. It should be 0.0023.
Okay.
Yes.
That worked.
Home run. First home run.
Sorry. Yeah, I think I kind of put that one.
Let's see, higher because of probability.
4 choices. Oh. Just by guessing.
All right, so if a similar test was given multiple choice with 4 choices for each question with approximate probability, guessing higher. I'll say lower because of probability guessing. It's lower for options. Yeah, so mine is the third option. Because in other words, it's saying if you have 4 choices instead of 2 choices, you know, would your chance be greater or lower to pass the test? And of course, it would be lower because now you have 4 chances to get, or 3 chances to get the wrong answer right if you have 4 and only 1 is right. So it's lower because the probability of guessing it correctly on each question is lower than the when there are 4 options. Because now it's a 25% chance that you would get it right. 1 out of 4.
Right.
Mhm.
Okay. Okay. That did help me. I appreciate that.
Okay. Okay.
I got
All right. So where are we going now? Or are we good for the night? Let me know.
let me look at these questions because I might be do them now that I had that help.
Mhm.
Yeah, I'm gonna just try to do these. If I have questions, I'll ask you next week.
Okay. And if you don't want to wait till next week, you always can, hit me up either for, either one of the office hours, or if we need to set up another time to meet, we'll just make it happen according to our schedules.
And your office hours were Monday and Friday and Thursday, correct?
Monday, Wednesday, and Friday. But
Wednesday.
if there's a if we can make a Thursday work or something like that, then we just have to talk it out and see what can work for both of us. Like one of your classmates, I ended up having to meet her on a Saturday one time. You know what I mean? So, I'll figure it out. We can figure it out if those office hours that are set, won't work for you. So,
Okay, thank you.
all right, no problem, no problem. You have a good one.
You too.
All right. Anybody else before I go ahead and close out? I think Miss Pinson walked away. All right.
I'm still here. No, I think I just got to learn how to read the Z-scores a little bit more, but I'll get it.
Okay.
Like I said, I gotta walk away.
Yeah. Okay, it's all good. You know how to find me.
Okay, thank you.
All right, you have a good one. All right, everybody, take care.